This is the demonstration of an outdoor activity that can be done with students. It's both multicultural and mathematical in nature. The mathematical part is that it is an application of the definition of an ellipse. Recall that an ellipse is a curve where the sum of the two distances to the fixed focal points or foci remains constant. The multicultural part is that it corresponds to laying out a foundation of a hare paenga or boathouse from Rapanui, which you might know as Easter Island. There aren't very many supplies needed for this activity. We have a rope and 2 stakes and another stick. So our rope is tied to these two stakes. We chose to use 37 feet. The stone foundations of the boathouses ranged in length from like 35 feet to 45 feet for many of them, but there were some also as long as 60 feet. So when the rope is pulled taut, that's going to give us the length of our foundation outline or our ellipse. And then you might notice I have 3 fingers up. So we're going to go from the major axis in 3 inches to where the foci are. So stretch it out tight, use 3 inches to move in for the foci. So where we're hammering in these stakes are our 2 foci or focal points for the ellipse. Now moving in the 3 inches is giving a little bit of slack to the rope. So taking a stick and pulling the rope so that it's tight, and then tracing out in the sand. And what is getting traced out is going to be an ellipse, because holding that rope tight, we've got the distances from the 2 foci. When we add those together, it's the length of the rope, so that's going to be remaining constant. So that is our definition of an ellipse in action. So we'll get one side drawn out and then move over. I'm going to do the other side of the ellipse, so keeping the rope taut. Now we don't know that this is the method that the Rapanui people actually used, but it is a method that does work, and the students can see the definition of an ellipse then actually in action. So they can see that the sum of the distances between the 2 focal points is the rope's length, and so that's always staying the same. And so when we're done, we end up with an ellipse.